###, the James Webb Space Telescope. Additionally known as Webb or JWST, the James Webb Space Telescope is a logical pioneer that has uncovered astonishing insights concerning stars, planets, cosmic systems, and other intriguing vast peculiarities, setting new guidelines for scientific fervor. Webb is hailed as the respected Hubble Space Telescope's replacement, with people from all over the planet trading photographs or utilizing crude data to make new insights. 1 year has passed since the James Webb Space Telescope unveiled its very first memorable picture of the universe, stunning space experts worldwide with its phenomenal detail. However, its latest finding presents a frightening image of the universe that we have never seen before. What has been discovered so far by the James Webb Space Telescope is offering more conversation starters than answers for researchers. Join us as we explore how the James Webb Space Telescope captures the most startling pictures of all time in history. The replacement for the Hubble telescope revealed new data about star formation, system consolidations, and the early universe just 1 month after the initial photographs were delivered. The photos were amazing, revealing the universe in dazzling detail. Since then, the number of discoveries has soared, providing researchers with a colossal data goldmine. The James Webb Space Telescope's observations of innumerable tarantulas, record-breaking space smoke, stars on the edge of cosmic explosion blasts, and other unbelievable heavenly items have been documented. This satellite observatory's cutting-edge innovation allows us to peer farther into space than ever before, revealing previously obscure insights regarding the universe. A new time in cosmology has unfolded due to the photographs, which can be so detailed. To celebrate the first year of the James Webb Space Telescope's operation, NASA released a picture that shows a small star-forming region in the Column Cloud complex. The picture shows planes emitting from new infant stars, as incandescent dust billows of different tones impact atomic hydrogen, which makes up the red dust. The presence of a circumstellar plate projects a shadow on a couple of stars, suggesting the probability of planet formation in the far-off past. While the image might show astronomical chaos, according to NASA, this heavenly nursery is minuscule and quiet compared to others. Moreover, many of the youthful stars in this space are about the size of our Sun or considerably more modest, making it the closest star-forming district to Earth. This image was captured by the primary camera of the observatory, the Webb Space Telescope's near-infrared camera, which captures enormous pictures in 2 unmistakable infrared ranges simultaneously. Furthermore, the Space Telescope has improved our knowledge of exoplanets, or worlds that orbit stars other than our Sun. James Webb is particularly good at observing massive exoplanets. The satellite observatory found its first exoplanet, LHS 475b, at the start of 2023. The planet is 41 light-years away and has a diameter equivalent to Earth. According to NASA, James Webb is the sole functional telescope able to order the environment of Earth-sized exoplanets. After that, the James Webb Telescope found evidence of long-on systems that, from a theoretical viewpoint, shouldn't have existed. Eva Swindon, a college student, and her global cosmic team have seen 6 colossal old cosmic systems called refrain breakers. These might completely impact the manner in which we ponder space. These huge systems might have appeared between 500 to 700 million years after the Big Bang, according to the specialists' results. Recently, the telescope's infrared sensors identified them through the utilization of these instruments, permitting us to look back in time around 13.5 billion years when stars and systems were much younger. The colossal mass of the universe's breakers has left researchers baffled. Worlds in the early universe ought to have been 10 to 100 times less than that. Their computations show that these 6 items might be billions of times heavier than our Sun. The total mass of all stars in one galaxy may be 100 billion times heavier than our Sun. Does the possibility of attempting to figure out something so monstrous make you feel uncomfortable? Despite the fact that most cosmic systems during this period are generally small and just beginning to extend marginally, a few beasts reach adulthood much more rapidly than others. It is unclear what would cause this or how it would operate. Penn State College cosmology and astronomy aide professor and study co-author Joel Lader expressed his bewilderment at the revelation of a new classification of items formed at the Big Bang. The discovery that the development of tremendous cosmic systems began at the very start of the universe's history challenges many of our recently held convictions about the state of cosmology. It appears our revelation is so out of the ordinary that it presents difficulties to the academic community. It throws into question the entire situation of how systems formed in the early universe. Surprisingly, gigantic describes the things. All cosmic systems in the range are viewed as infants since they are still during the time spent in development. Anyway, systems that are essentially as old as our own have been tracked down in the early universe, which was previously thought to be its beginning. Spectrometry, which isolates light into its part frequencies to empower more precise distance estimations, is still required to validate the results, leaving researchers scratching their heads. There are only a handful of recently found objects for which distance and mass have been confirmed. If the data is precise, universe creation needed to have been significantly more effective and quick than what is currently suspected. The way that spectrometry certifies our normal working frameworks-based deductions from the visuals is promising. For a really long time, researchers have tried to interpret astronomical history. Yet a solitary piece of hardware may hold the key to the perceptions of space and time that have long piqued the interest of researchers. It is not surprising that conflicting realities presented by telescopes could lead to an absence of clarity. Cosmologist Dr. Katie McBring decided to offer her insights into the matter to make sense of how this could be happening. She pointed out that the JWST has been providing evidence of worlds that appear to have started or evolved much sooner than what researchers had expected from their models. Don't stress, however, as MC pointed out. The telescope is capturing images of worlds more than 13 billion light-years away, and they are somewhat foggy. It seems like there hasn't even been enough time since the Big Bang for these large universes to have formed by the dates that cosmologists have been getting from the telescope. Many in the field feel this project may stress uncertainty on different hypotheses, including dark matter and the Big Bang. However, we ought to go further into the proof to find out for certain. The telescope captures amazing perspectives on close nebulae, yet fluffy little specks when it comes to faraway systems. The explanation is that various varieties are impacted by different pieces of the light spectrum. The Webb telescope can identify light from a source in two distinct ways. It might use a spectrograph, which works a bit like a prism, fanning out the light and examining the brilliance of each tone, or it can utilize filters that block everything except a select scope of varieties. They can then ascertain the redshift of the system by comparing this information with spectra anticipated for systems with similar attributes. What this redshift illuminates us is the precise moment in Big Bang history that we are witnessing. Incidentally, numerous worlds have an abundance of stars or stars that were too youthful when they would have lived. By examining model spectra, there are a number of potential clarifications for this. The photometric readings could have been off due to issues with the telescope's adjustment, or they might have been observing a group of universes that isn't representative of the standard or very little areas of the sky. Another conceivable clarification is that universe range models are designed for closer universes, which don't work well with cosmic systems further away. On the other hand, cosmologists would face the exciting possibility of having to completely reevaluate astronomical advancement if those cosmic systems are indeed very enormous and previous assessments were mistaken. However, it's not the only area where researchers have missed the mark. Notwithstanding innovative advancement, planets that are too enormous to exist have specialists extremely confused, with none more so than the discovery of a planet considered too massive for itself. This has prompted a reassessment of our system comprehension of planet creation and nearby planet group design, as well as the models created by cosmologists in the fallout. A planet that is multiple times as immense as Earth has been viewed as, according to research out of Penn State. Legend has it that this planet is in a planetary framework around the ultra-cool star LHS 354, a star that is multiple times less enormous than our Sun. Before this discovery, researchers didn't believe such a situation was possible. However, new evidence shows that the biggest planet in our planetary group is indeed circling one of the universe's littlest and coolest stars, an ultra-cool dwarf. We still have little familiarity with the universe, and this finding demonstrates it even more. A planet of this mass circling a star with such low mass contradicts our expectations. These stars might have started in huge gas and dust mists, and planets might emerge from the gas and dust that remains in the disk of material around the infant star. Later, it is not assumed that the planet-forming plate encircling the low-mass star LHS 354 contains enough solid mass to produce this planet. However, it exists, so we must now re-examine our hypothesis regarding heavenly and planetary development. A good relationship would be to compare the stars to an outdoor fire. In order to maintain your internal heat level, you must get closer to the fire as its temperature diminishes. Planets are no different. They need to be hot enough to support liquid water and should be closer to stars with lower temperatures. If a planet is in a sufficiently tight orbit around an ultracool star, we can see the pull of the planet on the star's light or spectra, which causes a small change in the star's color. Another stunning picture of the ice giant Uranus, highlighting almost all its dusty rings, has been snapped by the James Webb Space Telescope. This feat had previously been hard to achieve, with the fainter rings only visible through the Voyager 2 and WMK observatory on government rockets. The image is a stunning showcase of the telescope's responsiveness. Uranus, which is 1.12 billion miles from the Sun, has 13 recognized rings, 11 of which are displayed in the stunning new picture from the Webb Space Telescope. In contrast to Saturn's even rings, this planet's impossible-to-miss sides tilt causes its rings to appear vertical. The two outer rings were not distinguished until the 1986 flyby of the Voyager 2 spacecraft, as their dusty cosmetics made them less apparent and harder to photograph. The 9 significant rings were known before then. In 2007, photographs captured by the NASA Hubble Space Telescope revealed 2 more fainter outer rings that are not apparent in the Webb photo. Researchers believe the Webb can potentially capture them. A planet's ring system provides important data regarding its origin and beginning. Uranus is a very unique globe with its skewed orbit and non-appearance of internal heat, so any data regarding its past would be highly appreciated. The specific environmental cosmetics of the enormous gas-based planet Uranus is something that researchers are hoping the telescope can provide insight into, as no other telescope of this scale has ever been able to see infrared light. The JWST allows us to examine Neptune and Uranus through a sacred novel lens. Telescopes that utilize visible light, like Hubble, cannot observe infrared frequencies. Yet infrared imaging can uncover previously inconspicuous depths and include remarkable footage of a star nearing its demise. This has been captured by the James Webb Space Telescope, with JWST late 2021 sending the fading star image. This is the first faultlessly recorded event of its kind. The massive, dying star Wolf-Rayet 14 was caught on film by the telescope's infrared lens as it ejected gas and dust into space. It is believed that this divine event is happening 15,000 light-years from our planet. Not certain what it means, but it's around 58 trillion miles away. The image, which was provided simply by NASA, shows the glistening purple remnants of the star's external layer, which was previously a slight cloak of dust and gas, making the star flare. This staggering picture is an enhancement of the one that the Hubble Space Telescope captured a few years prior in 2015. Before the JWST was sent off, the star on the move was recorded by the Hubble Space Telescope. It appeared more like a blasting ball, but our technology could not catch the finer details. The destruction caused by Wolf-Rayet 14 is now clearly visible. The fact that the consumed star, which is believed to be located in the constellation Sagittarius, is multiple times greater than our Sun. Plus, it has ejected enough gas and dust to cover 10 suns for now, at any rate, according to NASA. A star is at the center of this dazzling new picture. For the last 15,000 years, that star's light has been advancing across the universe, requiring 15,000 light-years to reach the telescope's finders. What appears to be dust around the middle star is actually dust because of this. When a star dies, it releases its external layers and material into space, as found in the outline. Planets will form from this dust as it disperses into space. In reality, this is how we came to be. Scientists believe that a star in the process of shedding material is about to explode, a phenomenon frequently known as a supernova. Although the destruction of Wolf-Rayet 14 will be imperceptible to the human eye, 5 planets will be visible from Earth. Stunningly, a genuine beast in space had its appearance captured by the James Webb Telescope. The ghastly substance was seen by the JWST as it snuck through space. In reality, it's a cosmic system that produces many new stars every year, not some gigantic extraterrestrial. The universe, which has the designation Aztec C71, was initially found nearly 10 years ago by a ground-based telescope. However, when the more refined Hubble Space Telescope analyzed it, it vanished. With the assistance of the James Webb Space Telescope, the tragically missing cosmic system has now made a victorious return. The universe Aztec C71 appears as though it's shouting into the pit in a craftsman's depiction, which gives the appearance that it has 2 eyes and a vast mouth. Its tracking down modifies how researchers view the early universe and raises the plausibility that colossal star nurseries were 3 to multiple times more common than previously thought. According to the group's computations, the redshift of the universe being noticed is roughly 6, which places it at roughly 900 million years post-Big Bang. This thing's small mass is, in fact, responsible for the introduction of many stars every year. Regardless of appearances, what invigorates us is that our most current telescope produces pictures that are so delicate that even something so massive is scarcely perceptible. An enormous number of worlds might be revealing themselves to us in this manner since dust absorbs most of the starlight and transmits it at redder, longer frequencies. Dusty cosmic systems have proven challenging to photograph before. Our only method for noticing systems in the early universe had to deal with the optical lens of the Hubble Space Telescope, since our eyes are limited to the visible spectrum. Our insight into cosmic system development is slanted. However, the Hubble Space Telescope can't identify infrared qualities that the NASA James Webb Space Telescope can. Since JWST is sufficiently sensitive to look into the universe's farthest corners, even the thickest dust cloak, it will permit us to examine the optical and infrared qualities of this previously concealed gathering of universes. In an effort to early investigate the universe's highlights, the Universe Web Project plans to map up to 1 million cosmic systems from an area of the sky the size of 3 full moons. Notwithstanding the observatory's notoriety for gazing into space at the farthest conceivable distance, NASA has moreover used its complex sensors to make discoveries in our own backyard. Utilizing the itemized photos of Mars that Webb required last year, researchers can analyze more transient peculiarities like dust storms, atmospheric conditions, and seasonal moves. However, the red planet is a challenge for the powerful space telescope since the infrared light from Mars is blinding the instruments on board due to the very bright conditions. Stargazers needed to utilize specific data analysis strategies and very brief openings to compensate.